Hi, today we're going to cover how to factorize quadratics. You may have seen before that if we have two binomials and multiply them together, we can get a quadratic. In this case, we have x squared plus 2x plus 3x plus 6, giving this quadratic. However, what if we want to go the other way? What if we want to take a quadratic like this one and figure out which binomials multiply together to get it? Let's continue with this example quadratic. We know that we'll have two binomials involving x multiplied together. However, we don't know what goes here, nor what goes here. For now, we'll just use the placeholders p and q. To find p and q, there are two rules we can follow. The first is that p plus q needs to equal b. In this case, b is 9. Secondly, pq needs to equal c, which in this case is 14. So in order to figure out p and q from these two rules, it's easiest to start from the second rule here and to think about what factors 14 has. We could think about 14 and 1, but 14 and 1 don't add to 9. What about 7 and 2? Well, 7 plus 2 does equal 9, so therefore we found a p and q that are valid. So we can rewrite our quadratic in its factorized form, replacing p and q with 7 and 2. Let's have a go with another practice question. Here we have a quadratic, and let's start by writing down the rules involving p and q. We have p plus q equals minus 5, and pq equals 6. So, thinking about the factors of 6, we could think about 6 and 1, that doesn't add to minus 5, 3 and 2, that doesn't add to minus 5. So what else can we try? Well, don't forget about negative factors. We can try minus 3 and minus 2. If we have minus 3 plus minus 2, we do get minus 5. And if we have minus 3 multiplied by minus 2, we get positive 6. Remember that two negative numbers multiplied together gives a positive. So we found valid p and q values. Now we can substitute them in, and we have our factorized form. Hope that was useful. For more maths practice and help, check out usegomaths.com.